In 10.4, we're looking at combined inequalities, and all that means is you're dealing with more than one inequality. So let's take, for instance, a real-life example. Let's say your parents will let you go to the movie if you clean your room and you do the dishes. In mathematics, when we use that term and, that's considered a conjunction. So you have to clean your room and do the dishes. You have to do both in order for it to go to the movies. Now let's say your parents are nicer and they say, okay, in order to go to the movies, you can clean your room or do the dishes. That's considered a disjunction. So if I clean my room, I can go, or if I do the dishes, I can go. I don't have to do both. I could, but I don't have to. So let's look at some mathematical examples. Let's say, for instance, you have x is greater than -2 and x is less than or equal to 3. So I'm going to go ahead and graph this so you can see what it looks like. I'm going to use my ruler just to help me kind of get started with a number line. And so this is where I really would encourage you to use colors if you would like. Now before we start graphing, let's talk about some solutions, because with inequalities we many times have an infinite number of solutions. So what numbers are greater than -2? Well, 0 is greater than -2. -1 is greater than -2. 10 is greater than -2. So when I go to graph, I'm going to start at -2. I'm going to have an open circle there because it doesn't say it could equal it. And then I'm going to shade all of those solutions I just said. I'm going to shade -1, I'm going to shade 0. I could have said 1/2, but I'm going to shade all of those solutions. Now, I also, on the same graph, am going to look at when x is less than or equal to 3. So for instance, I'm going to go to 3, I'm going to put a closed dot. Now I need to figure out what numbers are less than or equal to 3. Well, 2 is less than or equal to 3, 0 is less than or equal to 3, -15 is less than or equal to 3. So when I go to graph that, I'm going to make sure I shade all of those numbers that are solutions. Now with an and, with a conjunction, in order for us to have true solutions, it has to be a solution that works in both. It works in the first one, which I graphed in red, and it works in the second one, which I graphed in blue. So really you're looking for the overlap. Anytime that we use that term and, we're looking for where is the overlap. And so if you think about it, ask yourself, what are numbers that are greater than -2 and less than or equal to 3? Well, notice in black, I highlighted where they overlap. We talked about this in the last section, but anytime it's an and, we potentially can combine that inequality. So if I start with my lowest number, -2, I can say, okay, -2 is less than x. That's true. And x is less than or equal to 3. I can combine this into one longer inequality. Okay, now let's look at something that is a disjunction. Let's say, for instance, y is greater than or equal to 2, or y is less than -2. So let's see what that looks like. I'm going to go ahead and start my solutions. So when I go to graph this first inequality, I have y is greater than or equal to 2. So I can put a closed dot at 2, and I'm going to shade everything that's bigger. So like 4 is bigger, 10 is bigger, So I'm going to shade this direction because those are my solutions. And then I'm going to graph the second inequality. So I'm going to do that in a different color. When I go to -2, I need an open circle because it can't equal. And then I think what numbers are less than -2? So -3, -5, you could go on. So when it is an OR graph, remember the solutions that you would include have to work in one or the other, but it does not have to work in both. That's only with and. So in terms of my answer here, really it's everything that's been graphed in this particular case. So for an OR graph, in this case, there's nothing really to write any simpler than the two inequalities with an OR in between.